Hello, and welcome to Comparatively Speaking, where we teach chemistry by analogy, or as I'm fond of saying, we teach the thing I was bad at in high school with the thing I was good at in high school. I've been avoiding this topic, because it's really challenging to find an analogy, and because it's the first time that I'm going to have to leave out a few things in order to kind of land the plane and get the point across. And I don't like doing that, but if I am going into electron configuration, and in order to make sense of kind of how it works for what we're going to next, which is bonding, I'm going to leave out some of the stuff about exactly how the electrons orbit the nucleus and where they go. I also was sort of avoiding this one because this is my fourth session in the same same clothes, but I've been asked to keep the costume consistent for Unit 1, which is atomic structure, and then when we move on to the next thing, I'll do some sort of costume change, hopefully, and get to retire the sweatshirt for a little bit. So should be hopefully a brief one. I'm just going to talk about the concept of valence, and the valence refers to the outer orbit, the outer region of an atom where only the outermost electrons are found. So let's talk a little bit about that. The valence is just sort of the exterior region. It's the only part of the atom that's accessible to other atoms. So we started with the pizza analogy, protons, neutrons, electrons. We moved on to isotope cans and how the neutrons are contributing to the mass of the atom in the nucleus. And then now we're going on to the electrons, and the fact that they don't contribute anything to the mass. They do have a charge, and in a normal atom, in a neutral atom, you've got as many protons in the middle as you have electrons around the outside. The protons are positively charged, the electrons are negatively charged, and even though their masses are totally different, the protons are much, much heavier, they are canceling each other out, and you get a neutral atom. And for now, we're going to leave it that way, because later we're going to talk about what happens if you change up your ions, your electrons, the way you change pizza toppings, and you would get ions. But for now, we're just saying, like, okay, protons in the middle, along with neutrons, electrons in a fairly complicated dance around starting, with just two of them near the nucleus and moving outwards, and the valence being just those electrons that are left. So one way you could say that is, I'm going to take, I want to go to the prom, and I want to go in a Maserati. So there's room for two, right? So it's just me and my prom date in the Maserati. And then anybody else that wants to go to prom or go to like my prom party afterward, you know what? I'm not comfortable with this. I'm not going to prom. It's been a long time. So I've got a set of cars, and the first one holds 2, and then the other cars each hold like 8. So I've got 2 people going in the cool car, and then 8 people in the next one. So it's like Maserati, stretch Hummer, I don't know, and then you just keep getting more cars. And that is the analogy for how the electrons initially start filling the regions around the nucleus. The valence refers to kind of that final car that like may or may not be full, that you have, whatever electrons are left over as you start filling. That's what's called your valence, and it means like sort of your exterior. That's one analogy. The real analogy I want to use for valence, I want you to think of the valence shell of the atom as being like a utility jacket that has 8 pockets. So you imagine you got this jacket, you love it, it's got like pockets here and here and on the sides and like in the back and maybe on the sleeves, it's got 8 pockets, and everywhere you go, you always wear your jacket. If you're super, super simple, maybe you're just going to the beach or something, maybe you're like hydrogen or helium atom and you actually don't wear the jacket, you just have your pants pockets, and you just have 2. So if you're a really small atom and you only have 1 to 2 electrons, then your valence is just those 2, right? It's just what you have on you. As you get to be, higher atomic number, which means more protons, which means correspondingly more electrons, you start to add more and more. And let's say at that point, you're always wearing your jacket. So maybe you are, for example, a sodium atom. You have 11 protons, therefore you have 11 electrons. You're going to have 2 and then 8 more, and then your jacket is just your outer layer, has 1 left over. Now here's where I'm oversimplifying. Believe me, you don't want me to go into greater detail on this, not right now. So you've got the first two electrons nearer to the nucleus, you've got room for 8 more, and then you're always wearing your jacket, but there's only one thing in your jacket pocket. If you're sodium, there's just one thing left over. So you've got 8 pockets, but there's just one thing in it, right? Let's say that you're magnesium. Add another proton, totally different elements. Now I've got 12 protons, I'm magnesium, and therefore 12 electrons, 2 and then 8. Now my jacket, 2 of the pockets of my jacket are full. What I'm getting at is you always have 8 pockets in your jacket, and then you're just, maybe it's not really that full, or maybe it is closer to being fully, saturated, all pockets filled. But the jacket is the idea that you have an outer layer to all, no matter how many layers you have on underneath. You could be a really large, much larger atom like cesium, and maybe that means you've got all these layers under your jacket, you're like filling with electrons, but your outer layer, your 8 pocket jacket, just has 1 electron in it. So cesium and sodium, they actually behave kind of similarly, we'll get into that later, because they each have just that 1 extra electron. But so think of that valence as being an outer layer. It's like a jacket, it's got room for 8 items, electrons, not always full, but it's the only thing that other atoms see when they interact with you. They just see your outer layer, your jacket. And I just realized as I'm about to land this analogy that I am wearing a distinctive favorite jacket. So I know that you have your choice of teachers who are not that self-aware and tend to wear the same clothes, and I'm just grateful that you've chosen this teacher for this analogy for this particular evening. So have a good night. Thanks for joining us.